In this session, we are discussing this step-down flyback converter circuit. Either it is mobile charger, either it is any voltage adapter. Most of the time, the circuit configuration remains same. It is without optocoupler. Let's see its function. I will explain its circuit in detail, and we will trace the circuit. We will draw its schematic here. If you don't have good experience in electronics, never try to repair, because here are unisolated live voltage. Take care for the safety. Assalamu alaikum wa rahmatullahi wa barakatuhu. I am your host Muhammad Ashraf, and I welcome you on my YouTube channel. If you are visiting first time, you can subscribe my channel. And if you want to watch videos in future, press bell notification and notification for all so that you will be notified for my future uploads. Two input terminals. This one and this one, line and neutral, because most of the time these are universal power supplies from 100 volt to 260 volt. In this portion we have a resistor here, that is fusible resistor. It is 10 ohm 1 watt resistor. Most of the time the resistors are non-inductive, but this one is normal wire wound resistor. Then it is connected at this component. This is neutral side. It is connected to this component. Its one pin is here, second is here. It is MOV, metal oxide resistor. It is non-linear resistor. Any kind of high voltage strike will cause to decrease its resistance. It will cause to flow more current here. If the strikes are repeating again and again, that will cause to blow this resistor, so next circuit will be protected from high voltage strike. This resistor is working as a fuse resistor, and also it protects from inrush current. Then line and neutral are reaching to bridge rectifier. This MOV part number is 10D471K. 471K clamping voltage at 1 milliampere, 470 volt. This is initial clamping point when MOV function will start to clip the voltage. Below this 470 volt, it will remain off. Its internal resistance will remain very high. We have this bridge rectifier. NB6F. Then we have capacitor here. That is this capacitor. Its value is 4.7 microfarad, 400 volt. This end is positive and this end is negative. We can see here is a disconnection. Yes, here is damaged joint, broken track. So that is the reason this circuit was not working. This negative line is separated from this point. It was not passing to next circuit, so this was disconnection. Then negative voltage will reach to this jumper. It is known as L1 inductor. It is working as an inductor or 0 ohm resistor. From positive side, from this point, because this is bridge rectifier positive terminal. Positive voltage will pass from this component. Here C2 not installed. So that is this one. It is L2 inductor. Brown, black, red. It is connected in positive line. brown, black, red. 1 millihenry, last silver 10%. That is this inductor. Then we have this capacitor. Here is also capacitor. This end is positive and this end is negative, that is coming from this inductor, this resistor, this jumper. Negative terminal from the bridge rectifier, capacitor negative terminal, then here, then it is reaching to this point. So we have another electrolyte capacitor. It is also same value, 4.7, 400 volt. 4.7 microfarad, 400 volt. Then these positive voltage are reaching to these components and it is reaching to this point. Here is transformer primary winding. That is this transformer. It is flyback transformer. Primary winding 1 end, second end is connected to this point. This IC is very strange numbered IC. NB2 JL7K2VS. I was unable to find its data sheet, so that is reason I am making this circuit diagram. Maybe it will be useful for someone. Pin number 5, pin number 6, 7 not connected. NB2, some manufacturers print some strange number, JL7K2VS. Pin number 8, that is this pin, it is connected to ground point. From this point, that is this negative terminal, here underside is IC, it is reaching to pin number 8 and this resistor. This point, pin number 8. It is also primary ground. It is unisolated ground. It is not safety ground, it is primary ground. Then from the same positive terminal, that is this one, from underside of this bridge rectifier, the track is reaching here. Here is 305, 2 resistors. This positive terminal, that means 300 kilo ohm. It is also 300 kilo ohm. This 300 kilo ohm resistor, this end is reaching to 300 kilo ohm, then it is reaching to 1 R0, 1 ohm resistor. And then it is connected to a capacitor. 1 ohm resistor here, from underside this capacitor, it is reaching at this point. It is positive terminal of the capacitor. Negative terminal of the capacitor is connected to primary ground. That is coming from bridge rectifier, that is this one. That is this small capacitor, 1 microfarad, 50 volt. Capacitor this point is connected to pin number 3. It is VCC pin. If you see these two joints, this one and this one, this is auxiliary winding of the transformer. The same transformer, I will make its one winding here. One end is connected to ground, that is this one. It is reaching to primary ground. Second end is connected to F7 rectifier. It is fast rectifier. Then this rectifier is connected here. This rectifier, Here 1 ohm resistor, it is reaching to VCC pin. When we will apply power, these resistors will provide charging current to this capacitor to provide a delay start until these capacitors will obtain its rated value charge. Then this IC will start switching. When IC will start switching, it will drive this transformer, that is this one. This magnetic field will induce voltage here. Running current for this IC will be provided from this rectifier to this path. Sorry, here is a mistake. We will connect this point here. So current will pass from this 1 ohm resistor, not here. It will not reach directly, it will reach from this 1 ohm resistor. At the same point, that is this one, transformer winding. The same point is connected to a resistor, that is 29C. This point is connected here, 29C. This resistor is 19.6 kilo ohm. 29C is EIA 96 code for 19.6 kilo ohm, 1% tolerance resistor. So it is precision resistor. Then we have 123, that is 12 kilo ohm. Center point. Now we can check here. Resistor this end is connected to the pin number 8, and these points are connected together, and it is reaching to pin number 1. This center joint will reach to pin number 1. So it is feedback pin, or you can say zero crossing detector. It is for feedback. It will determine the load. If more current is being drawn in the output side, that will create more current in this winding, because it is flyback transformer. First it will store energy in the transformer core. In off cycle, it will transfer that energy into the secondary. That voltage will reach here, and also due to more current flow in the secondary, more voltage will here. So amplitude of the voltage will determine the load size. So it will maintain its duty cycle to provide more current. Transformer this point, primary side, that is this pin. We have 4 components here. At pin number 5, we have a diode. It is S1M Schottky rectifier. Then it is connected to 514 resistor, and that is connected to positive terminal. Here we have 510 kilo ohm resistor, that is 514 code. It is connected to this rectifier. Then we have second resistor here, that is connected to positive terminal. It is 101 code, 100 ohm. That is connected to this capacitor. One end is connected to positive terminal, second end is reaching to this capacitor. It is connected to rectifier. So it is RCD snubber circuit. Now we have pin number 1. Pin number 2 is connected to a capacitor. Most of the time it is compensation capacitor. In some ICs it is frequency setting capacitor. I think it is compensation capacitor. One end is connected to ground, second end is connected to pin number 2. We can find its value by its dielectric material, because it is in white color. Maybe it is frequency setting capacitor. Pin number 4, we have 2R40, 2.4 ohm SMD resistor. It is current sense resistor. It will also determine the amount of current. it will provide feedback, and it will determine the load current, and it will also determine the current in the output MOSFET. Then we have these output components. In the output side, we have this winding, one end, and this is second end. At this end, we have SS34L Schottky rectifier. SS34L. In parallel to the SS34L, we have 47 ohm resistor and a capacitor. It is RC snubber 47R, and capacitor value, we can find its value by finding its size code and dielectric type. Then cathode is connected to this component. Here we have capacitor. Low ESR value 105 degrees Celsius temperature, 470 microfarad, 16 volt. Output ground. Here we have output voltage. You can see the circuit became very simple and easy. We will apply voltage here. This resistor will protect the circuit from inrush current, and it will also behave like a fuse. Here we have 10D471K MOV metal oxide resistor. It will protect the circuit from high voltage strike or over voltage stress. If there is high line swelling, it will become short circuit. It will protect the next circuit. Bridge rectifier MB6F SMD bridge rectifier. It will provide rectified voltage on these capacitors. We have two capacitors here. Both capacitors are separated by these two components. One is 0 ohm jumper, working as a resistor and also working as an inductor. One inductor 1 millihenry, that is this green color component. Then it is reaching to 4.7 microfarad. Input voltage multiply with 1.414, we will find DC voltage here. Let's suppose 220 volt here, 310 volt, 311 volt on these capacitors. Positive voltage will reach to this transformer winding. This transformer winding will receive return path from its output side MOSFET. To start this IC, we need positive voltage 300 plus 300K, 600K resistor will charge slowly to this capacitor, 1 microfarad 50 volt. When voltage will reach at specific threshold, this IC will start switching. It will provide pulses here to the MOSFET gate. Then it will provide these rectified voltage. This common here, positive here. We have positive here, just a pulsed voltage will reach here. Controlled current will flow in this winding. That will create magnetic field. That magnetic field will be stored in this core. In turn on time, it will store energy, magnetic energy in the core. When this MOSFET will remain off, in off cycle, it will stop the current. RCD snubber will discharge this magnetic field, because when magnetic field will collapse, it will provide reverse EMF. So this end will become positive, winding this end will become negative. So it will pass that voltage to the resistor and this capacitor. That stored energy will be transferred in the secondary winding. That will be rectified through the Schottky rectifier, and we will find voltage here. It will charge this capacitor, and here we will connect RL, load resistor. When it is transferring voltage in secondary, we have another secondary that is called auxiliary winding, VCC winding or bias winding. So that bias winding, VCC winding or auxiliary winding will create voltage. The first function, it will provide rectified voltage through this resistor to the capacitor to the pin number 3 of this IC, that is VCC. Also, amplitude of that voltage will be used as a zero crossing detector or feedback. That will provide two different jobs. First, zero crossing detection, and amplitude will determine load size. If there is no load, less voltage will here. If more current is flowing in secondary, that will create more voltage here. That will cause to provide more feedback here. So this IC will determine how much load is there. Same time, how much current is flowing in this channel. That current will be measured by this current sensor resistor. It will sense the dropped voltage here to calculate its duty cycle. So this is the function. Let's connect power and we will see this IC is unknown. I was unable to find its data sheet. I will solder the broken joint of this capacitor. If we have any circuit that is looking similar to this IC, you can use as a reference. Moreover, if you have any experience about this IC, if you know the number of this IC, what is the base number, what is the original number or equivalent, you can mention in the comments. Right now I am making jumper by solder. Then I will connect it using a jumper wire. I will apply power using series lamp. Never touch any component within the circuit when power is applied. I applied AC voltage. We have 227 volts. And if we check DC voltage, second capacitor, that is this one, 314. First capacitor, 314. We have voltage here, we have voltage here. That means this circuit is working good. If we cannot find voltage on these capacitors, then we need to check this portion. Might be bridge rectifier is damaged, maybe the fuse resistor is open circuit. In this situation we have voltage here, and now we will check voltage on VCC capacitor, 13 volt. If we check output, we have 8.3 volts. If we cannot find voltage in the output, first we need to verify voltage here. If voltage are good, then we need to check VCC voltage here. If IC is restarting again and again, might be this 1 ohm resistor, might be auxiliary winding, this diode, or maybe there is something short circuit in the output, so we will find fluctuations. If we cannot find full rated voltage, in that condition we need to check these RCD snubber components. Now I will check frequency. I am checking frequency across VCC winding. It is switching at 7.3 kHz. It will adjust the frequency depending on the load size. When there is no load, it will maintain the output voltage by decreasing its switching frequency. When we will connect load, this zero crossing detector and feedback network will provide information to the IC that there is load. If we cannot find output, might be the IC is damaged. Sometimes the transformer winding is open circuit. In that situation, we will remove power, we will discharge the capacitors, and we will find continuity or resistance of the primary winding. I hope this video is informative for you. If it is good, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.